Hello everybody, today we're going to look at how to use z-distributions and quantiles. Okay, let's go straight into the examples. So in this first one, we're going to compare two different scores in two different distributions to see which one was the best. So Kelly scored 73% in history, where we're given the class mean of 68% and a standard deviation of 10.2%. And then in math, she scored 66, where the class mean was 62% and the standard deviation was 6.8%. So we now need to work out in which of these two classes, history or math, did she do the best in comparison to the other people in her class. So let's talk about history first. And for this, we're going to use a formula that you can find in the formula booklet, and it's how to map things to the standard normal, right? So we can take each value, we can subtract the mean and divide by the standard deviation, and that will take that value and place it in a standard z-distribution. And we'll do that for both history and math, and then we can compare where we are on the z-distribution to see which was the better score. So for history, we're going to have 73 the score, take away 68, which was the mean, divided by 10.2, and if we work that out, it comes out as 0.490. And then for math, we can do exactly the same thing for the math distribution. We know we scored 66%, so if we take away 62, the mean for math, and divide by 6.8, we'll have mapped that also back to the standard z distribution. So in that case, it was 0.588.
Okay, so the question is, what does this mean? Well, it means that
on average, let's think of it like this, in math, they scored 0.588 standard deviations above the mean. And in history, they scored 0.490 standard deviations above the mean. So therefore, they did better in comparison to their peers in the math, because we have a higher or further away from the mean in math than we were in history. Now, let's go on to question 2. This is a really simple question, because I'm not going to go through it in too much detail because it's exactly the same as the last lesson. We have to use technology to illustrate and calculate certain certain probabilities in a z distribution. So notice in this question that we have z rather than x. That just means that for each one of these questions, we have a mean of 0. And we have a standard deviation of 1. So in this first example, if I was asked to make an illustration of this, which I am looking at finding the probability or the area of that shaded section there. If I am looking at part B, then I am looking to find the probability of being less than 1.5. And if I'm looking at part C, I'm looking at the probability of being greater than 0.84. I'm looking for that probability there. So that is the illustrations of all three parts. And I'm just going to put this into my calculator. So just to give you a really explicit understanding, I'm going to be using the normal CDF button on the distribution list of my calculator, and I am going to say for the first example that the lower bound is going to be negative 0.41, the upper bound is going to be positive 0.67. We've got the mean is 0, we've got the standard deviation is 1. We press the button, we get the answers, and I believe that in this question we have an answer of 0.408. So just check and see if you can get the same outcomes as you should get for each of these questions. In part B, you should get 0.933, and in part C, you should get 0.200 as your answers. Okay, so they're very simple questions. I've done those before. It's just that when you see this Z, you just instantly know that the mean is 0 and the standard deviation is 1. Okay, let's move on to another one now. So this is our first look at quantiles, which are backwards kind of reverse normal distribution questions. So if Z is a standard normal distribution, find K such that probability of us being greater than K is 0.73. Okay, now what we're going to do, let's have a little visual of this. So we need to find this particular point where the probability of being greater than it is 0.73. So imagine we've got this sort of thing happening here. We are trying to find this value K here. Okay, so we need a new button on our calculator. We need to use the inverse normal button. So find out the inverse normal button on your calculator. It is through the distributions list. If you scroll through, you should see, I think it's the fourth one down. Now, for this one, we need to type in some things. So we need to know the area, which is 0.73. We're given that in the question. We need to know the mean and standard deviation. Well, we're told in the question it's the standard normal distribution z, so we know that as well. And really importantly, we're asked for the tail. We're asked if it is either to the left or to the right. So clearly, we are to the right of the quantile k that we're trying to find. So we want to select right here. Now, if you don't have this option on your calculator, the default is to the left. So it will have to be 0.27. Okay, if you don't see a choice of a tail, that's what you're going to have to type. So press enter, and we should get our answer. It is going to be negative 0.613. Okay. So I hope that makes sense. Now then, just a quick understanding of this though, okay? Below, you can see some outcomes when I've used this button on a few different occasions. Now, if I am doing, like I did just now, 0.73 to the left, okay, to the right, there's my answer, look there. Okay, but that would be the same thing, wouldn't it, as doing 0.27, but to the left, and those two things are identical. Okay, so you could do it in both of those ways. This whole system is symmetrical as well. So if I wanted to do 0.27 to the right, and I was over on this side, right, okay, to the right, and I knew that was 0.27, well, that's going to give me the positive answer, exactly the same, but positive. And that is repeated down there. If I went to the left as 0.73. So just have some understanding of what we're doing and the visual and the understanding of the picture comparative to the calculations on your calculator. Okay, now we'll do one more very quick example and then it will be time to do some questions yourself. So a university professor determines that no more than 80% of this year's history candidates should pass the final examination. The examination results were approximately normally distributed with a mean of 62 and a standard deviation of 13. Find the lowest necessary score to pass the examination. Okay, well, let's draw a picture. So we want 80% to pass. So that means we're going to need to have 80%, or perhaps it'd be better for me to write 0.8 as the given area. So what's the value of k that we need? Now, we are also told in this question that we've got a mean of 62 and a standard deviation of 13. So we're going to type this stuff into the inverse normal. So inverse normal. Okay, we're going to type in mean is 62, standard deviation 13. We're going to say that our probability is going to be 0.8 and our tail is going to be to the right. Or we could put 0.2 and tail to the left. Press the buttons, we should end up with an answer, and that is 51.059. So this is, in the context of the question, the kind of percentage that you'll need to get in order to pass. However, in the context of a history exam, we're probably going to be rounding to the nearest percentage. And in that case, because of the context of the question, no more than 80%, we're actually going to have to round this up to 52, okay? And that way we definitely won't go past the 80%. If we round it down to 51, it might be that just over 80% got through because of that rounding. So it's going to have to be 52% for this particular question in this particular context. Okay, from there, you can have a go at some of these questions then. So try 24C, and that's on the Z distribution, and then 24D.1, and that is on the quantiles. Good luck.